The James Webb Space Telescope, also recognized as JWST or Webb, is a scientific trailblazer that has uncovered remarkable details about stars, planets, galaxies, and other cosmic phenomena. Similarly, it has set new standards for scientific exploration. Webb is hailed as the venerable Hubble Space Telescope's successor. People from all over the world are exchanging photographs or using raw data to create fresh insights. A year has passed since the formidable James Webb Space Telescope unveiled its first-ever image of the universe, surprising astronomers around the world with its fantastic detail. But its most current finding is a striking image of the universe that we have never seen before. What has been located so far by the James Webb Space Telescope is posing more questions than it answers for scientists. Join us as we explore how the James Webb Space Telescope captured the most terrifying photograph ever seen in history. The successor to the Hubble telescope unveiled new data about star formation, galaxy mergers, and the early cosmos just 1 month after the initial images were released. The pictures were breathtaking, revealing the universe in stunning detail. Since then, the number of discoveries has skyrocketed, providing scientists with an invaluable treasure trove of information. James Webb Space Telescope observations of cosmic tarantulas, record-breaking space smoke, stars on the verge of supernova explosions, and other exceptional celestial objects have been documented. This satellite observatory's cutting-edge technology allows us to see farther into space than ever before, revealing previously unknown details about the cosmos. A new era in astronomy has dawned thanks to the images, which are so precise. To commemorate the first year of the James Webb Space Telescope's operation, NASA released an image showing a tiny star-forming region inside the Roff-Yuki cloud complex. The picture shows jets erupting from newborn stars as cosmic dust clouds of diverse colors collide. Molecular hydrogen makes up the purple dust, and the presence of a circumstellar disk casts a shadow on some stars, suggesting the possibility of planet formation in the distant past. While the photo may show cosmic mayhem, NASA states that this stellar nursery is tiny and peaceful compared to others. Additionally, many of the young stars in this region are about the size of our Sun or even smaller, making it the closest star-forming region to Earth. This photo was captured by the main camera of the observatory, the Webb Space Telescope's near-infrared camera, which captures cosmic images in stunning infrared spectrums. Moreover, the Space Telescope has advanced our understanding of exoplanets, worlds that orbit stars other than our Sun. James Webb is particularly adept at observing large, distant galaxies. The satellite observatory observed its first exoplanet, LHS 475b, at the beginning of 2023. The planet is 41 light-years away and has a diameter comparable to Earth's. According to NASA, James Webb is the only operational telescope able to classify the atmospheres of Earth-sized exoplanets. The findings demonstrated how precise the telescope was, and rocky exoplanets are now a new frontier for astronomers to explore. After that, the James Webb Telescope discovered evidence of long-known galaxies that, from a theoretical standpoint, shouldn't have existed. EVOL Lab of Swinburne University and his international astronomical team observed 6 giant ancient galaxies, called universe breakers, which have the potential to completely change how we think about space. These enormous galaxies may have come into existence between 500 and 700 million years after the Big Bang. Using these units, we can glimpse back in time about 13.5 billion years, when stars and galaxies were much younger. The vastness of the universe breakers has left scientists bewildered, as galaxies in the early universe should have been 10 to 100 times smaller than these. Their calculations indicate that these 6 objects may be billions of times heavier than our Sun. The sum of all the stars in just one galaxy is probably 100 billion times heavier than our Sun. Does the thought of trying to understand something so massive give you the willies? Although most galaxies during this era are quite tiny and are just increasing ever so slightly, some monsters mature far more quickly than others. It is uncertain what would cause this or how it might work. Penn State University astronomy and astrophysics assistant professor and study co-author Joel Leah expressed his astonishment at the discovery of a new category of objects formed at the Big Bang. The discovery that the development of massive galaxies began at the very beginning of the universe's history challenges many of our previously held beliefs about the state of science. It seems the discovery is so out of the ordinary that it poses challenges to the scientific community. It throws into doubt the entire idea of how galaxies formed in the early universe, much larger than anyone expected. This phenomenon describes how all galaxies in this range are considered babies, as they are still in the process of formation. However, galaxies as old as our own have been found in the early cosmos, which was previously thought to be its beginning. Spectrometry, which separates light into its individual wavelengths to allow more accurate distance measurements, continues to be required to validate the results, leaving scientists scratching their heads. There are only a handful of recently discovered objects for which distance and mass have been tested. If the data is correct, galaxy creation would have had to be much more efficient and rapid than what we now think. The fact that spectrometry corroborated our current operating systems based on inferences from the visuals is promising. For years, scientists have sought to decode cosmic history, and while a single piece of machinery might hold the key, observations of space and time have long piqued the interest of scientists. So it's not surprising that conflicting data presented by telescopes might result in a lack of clarity at this point. Cosmologist Dr. Katie Mack has chosen to provide her insights into the matter to explain how this might be happening. She discussed the fact that JWST has been providing evidence of galaxies that seem to have originated or matured much earlier than scientists had predicted from their models. Don't worry, as Mack noted, the telescope is taking pictures of galaxies over 13 billion light-years away, and they are quite blurry. It seems like there hasn't been enough time since the Big Bang for those large galaxies to have formed according to the dates that cosmologists have been receiving from the telescope. Many in the field have been concerned that this throws out various theories, including dark matter and the Big Bang, but we need to delve further into the evidence to discover for certain. The telescope captures breathtaking views of close nebulae but fuzzy little dots when it comes to distant galaxies. The reason is that different colors are affected by various elements of the light spectrum. The Webb telescope can detect light from a source in two different ways. It can utilize a spectrum by spreading out the light with a spectrograph, which works a bit like a prism, and analyzing the brightness of each color. Or it can use filters that block all but a selected range of colors. Scientists can then calculate the redshift of the galaxy by comparing this data with spectra predicted for galaxies with similar characteristics. What this redshift tells us is the exact point in cosmic history that we are observing. It appears many galaxies have an excess of stars or stars that were too young when they would have lived according to comparisons of model spectra. There are a number of possible causes for this. The photometric readings could have been off because of issues with the telescope's calibration. Alternatively, they may have been located in a cluster of galaxies that is not representative of the norm, or very small regions of the sky. Another possible explanation is that galaxy spectrum models are designed for closer galaxies, which do not work well with galaxies farther away. On the other hand, cosmologists might face the exciting prospect of having to rethink cosmic evolution if those galaxies are indeed extremely large and earlier estimations were wrong. Wouldn't you agree? But it is hardly the only place where scientists have fallen short. Despite technological progress, planets that are simply too big to exist have experts very perplexed. None more so than the finding of a planet that is deemed too massive for its star, which has prompted a reevaluation of our collective understanding of planet creation and solar system architecture. Additionally, the models developed by astronomers in the aftermath of the discovery of a planet 13 times as large as Earth in a planetary system around the ultra-cool stone star LHS 3154 have changed our perspective. A star that is 9 times less massive than our Sun, according to a news statement, has a mass ratio 100 times greater than Earth's ratio to the Sun. Prior to recently observing it for themselves, scientists didn't think such a scenario was feasible. But new evidence shows that the largest planet in our solar system is indeed orbiting one of the universe's smallest and coolest stars, an ultra-cool dwarf. We still know very little about the cosmos, and this discovery proves it even more. A planet of this mass orbiting a star with such a low mass defies our expectations. These stars may have originated in large gas and dust clouds, and planets may have arisen from the gas and dust that remain in the disk of material surrounding the newborn star. After this, it's not expected that the planet-forming disk surrounding the low-mass star LHS 3154 would contain enough solid mass to produce this planet. But it exists. Therefore, we must now reconsider our theories concerning stellar and planetary formation. A good analogy would be to compare the star to a campfire. In order to maintain your body temperature, you need to get closer to the fire. As its temperature decreases, planets are no different. Planets are subject to gravitational forces just as we are to a campfire's warmth. The planet must be much closer to the star in order to gain enough gravity to maintain its orbit. Since it is significantly lower in mass and cools much more quickly than a star of greater mass, our understanding of planetary formation and evolution may need to be revised in light of the discovery of this massive planet. This planet was found around a low-mass star that was previously thought to be an unlikely host. Although planets with diameters up to 12 times that of Jupiter have been discovered by scientists, the more we learn about space, the more we are forced to reconsider what we previously thought to be true. It has always been the goal of astronomers to understand how everything works in space, and the Webb telescope may ultimately provide the missing pieces. The James Webb Space Telescope is actively observing Jupiter's moon Europa for signs of life in our solar system. The second Galilean satellite has long been considered one of the most likely places to host life beyond Earth. Although it is icy, scientists believe there is a large subterranean ocean beneath it, and the ice shell of Europa is even more intriguing. In addition to surface fractures and a chaotic surface environment akin to the Arctic, the ice shell has massive plumes of water vapor emerging from it. It appears that the plumes originate from the ocean. Scientists will look into the surface's properties and chemical makeup in detail using the infrared capabilities of the James Webb Space Telescope. Given the opportunity to look for chemical signatures of life on Europa, Webb may be able to search for plumes erupting from the surface while astronomers discover intriguing chemistry that is the first indicator of the possibility of life. It is expected that the JWST will yield many more unexpected results. The James Webb Space Telescope, JWST, is a marvel of modern science, standing as a monumental achievement in space exploration. This unparalleled observatory has propelled our understanding of the cosmos forward by providing clear, deep, and accurate images of celestial phenomena. While it took years of preparation and scientific development, the JWST has far exceeded expectations in its capacity to peer deeper into space and capture details that were once out of reach for previous instruments. One of the most notable features of the JWST is its ability to observe in the infrared spectrum, which gives it a unique advantage over optical telescopes like Hubble. Infrared light, often invisible to the human eye, allows the JWST to detect objects that are obscured by interstellar dust or faint due to their vast distance. By capturing these wavelengths, the telescope offers a clearer view of objects that are located in the early stages of the universe, some dating back to when the first stars and galaxies were formed. This ability to detect faint infrared light has provided groundbreaking insights into the formation of early galaxies, black holes, and the complex mechanisms driving star formation. In addition to its infrared capabilities, the JWST is equipped with advanced spectrographs that allow scientists to analyze the chemical makeup of distant objects. By dispersing light from stars and galaxies into their individual wavelengths, astronomers can determine the presence of various elements and molecules. This ability is crucial for studying exoplanets, as it allows researchers to investigate the atmospheric composition of planets outside our solar system. The detailed spectra captured by the JWST have revealed the presence of molecules like carbon dioxide, water vapor, and methane in the atmospheres of exoplanets, providing new insights into their potential for habitability. The telescope has also provided a wealth of data on star birth and death, revealing the chaotic yet beautiful processes that occur in stellar nurseries. These regions, where new stars are born, are often filled with dense clouds of gas and dust, and the JWST's infrared vision can penetrate these regions to uncover the hidden stars forming within. Moreover, by observing dying stars at the end of their life cycle, the telescope has captured the dramatic processes leading up to supernova explosions. These cosmic events, which mark the death of massive stars, play a key role in the evolution of the universe, dispersing heavy elements into space that later form new stars, planets, and even life. As part of its exploration of the universe's history, the JWST has also provided important insights into the evolution of galaxies. The discovery of ancient, Massive galaxies that existed just a few 100 million years after the Big Bang has upended previous models of galaxy formation. These galaxies, which are far larger and more mature than scientists had anticipated for that time period, challenge our understanding of how galaxies grow and evolve. Such findings have led to new questions about the rate at which galaxies form and mature in the early universe, requiring astronomers to rethink established theories. The JWST has also made significant contributions to our knowledge of the early solar system. The telescope has observed objects like comets and asteroids, providing new insights into the building blocks of our own planetary system. In particular, it has been able to study the composition of these objects in unprecedented detail, helping scientists understand the conditions that existed in the early solar system and the processes that led to the formation of Earth and other planets. Another area of focus for the JWST is the search for life beyond Earth. While the discovery of extraterrestrial life remains elusive, the telescope has provided valuable clues about the potential for habitability on other worlds. Its observations of moons like Europa, which is thought to have a subsurface ocean beneath its icy crust, have raised the possibility of finding life in our own solar system. With its infrared instruments, the JWST can detect plumes of water vapor erupting from Europa's surface, which may contain signs of microbial life or the conditions necessary for life to exist. The scientific community continues to reap the benefits of the JWST's groundbreaking observations, and the discoveries it has made so far represent just the beginning of what promises to be a new era of astronomical exploration. As the telescope continues its mission, it is expected to provide even more remarkable insights into the nature of the universe, from the formation of the first galaxies to the potential for life on distant exoplanets. With its unmatched capabilities, the JWST is poised to answer some of the most profound questions in science and shape our understanding of the cosmos for generations to come.